Stylianos, and this is a video where we will try to solve part 1 from the AP Physics C Mechanics exam of 2021, which is a free response question related to dynamics and kinematics. Basically, we'll try to find forces and kinematic quantities like velocity and acceleration. Our strategy remains the same. We try to figure out what is happening on the diagram and scan quickly the question. So what we see is a cart probably will be moving to the right since the fan applies a force, and later it moves on an inclined plane. And quickly we try to figure out where does the motion happen. So at the first 3 seconds, the cart is moving on the horizontal track, and later it makes a transition to the incline, and we can measure the acceleration again, and we need to figure out if there is any friction, which we can see that there is a track of negligible friction. So we need to see what else is given. We have the acceleration with respect to time graph. For the first 3 seconds, the acceleration is positive, and for the next, after the 3 seconds, the acceleration is negative. We have to be a little bit careful here. The reason why we have positive and negative acceleration on the 2 graphs is because the cart goes away from the motion detector 1, so we have positive displacement. That's why the first motion detector finds a positive acceleration, and later the cart moves towards the motion detector. So for the motion detector there is negative displacement, that's why the acceleration is measured as negative, but it's not really negative. The object will be speeding up. Now we need to figure out what is the acceleration on the 2 graphs. Carefully, we can see that the distance from 0 to 2 is spread out in 5 blocks, so 2 divided by 5 is 0.4, each block is 0.4, and the graph is at the 2 blocks, so the first acceleration is 0.8 meter per second squared, and on the inclined plane in a similar way it will be 2 plus 0.4, so it will be 2.4 meter per second squared. The negative is not really important, it's just what the motion detector measures. Now we can try to continue to the question itself, which is to draw a free body diagram on the cart. Simple, quite simple, I would say. There is the force from the fan. In reality, this is the force from the air to the cart. And since we're living on planet Earth, there is force of gravity, and there is the force from the floor, normal force. This force by the fan is still applied as the object is moving down on the inclined plane, so there is the force by the fan, and we have exactly the same force of gravity. The only thing that changes is the direction of the normal force, which is perpendicular to the floor of the inclined plane. And part A is done. Then we need to find the net force exerted on the fan cart as it is moving on the horizontal track. I would also say quite simple, F net is equal mass multiplied by acceleration. My guess is that the value of the mass is given somewhere. Indeed, it is 0.5 kgs. So 0.5 multiplied by the acceleration, that was 0.8. So the F net is 0.4 Newton. Now we have to be a little bit careful here. Although the question is about the F net, we need to keep in mind that this is in reality the force by the fan. So maybe we'll use it later. This is 0.4 Newton, or it was the mass times the acceleration of the first part of the first segment of the motion. Later we need to find the inclined plane angle. For this we will work on the inclined plane, where again we will try to apply the same law, F net is equal mass times acceleration. Now we have to be a little bit careful. For the purposes of the diagram, I will draw this on the dot, but you'll have to remove it from your answers as you are writing on the answer sheet. This force of gravity has two components, a vertical that we call Fgy and a horizontal that we'll call Fgx. And in reality it is mass times g times sine of the angle theta. So on the horizontal direction, there are two forces that are acting, the force by the fan and also the horizontal component of gravity, which is mg sine theta. And this is equal to mass times acceleration. Now the force by the fan, we found it 0.4. The mass times g, it is 0.5 times 9.8, so 4.9 times sine theta, is equal mass times acceleration, so 0.5 multiplied by the acceleration of the inclined plane, which was 2.4. And if we proceed with our calculations, we have 0.5 times 2.4 and then minus 0.4, the result is 0.8. It is equal to 4.9 sine theta. So the angle theta is inverse sine of 0.8 over 4.9. And if we go to the calculator, inverse sine of 0.8 over 4.9, we bring 9.39, so the angle theta is 9.4 degrees. We're done with part C, and we continue to part D, where after an examination we see that the incline is 3 degrees larger than what we calculated, and maybe the reason why we made the mistake is the following. The scale used to move the mass was not calibrated properly, and this could account for an observed difference in the angle. Now, in order to see if this statement is correct or not, we need to go to the equation that gave us the angle. So it was this equation, F of the fan plus mg sine theta is equal m times a. I tend to agree with this, but no, actually I was wrong. Now, if you remember the force by the fan, we said that it is m times a. So I'm going to replace this m times a plus mg sine theta is equal m times a. And since there is no friction, actually the mass should not be a factor here. So since the mass is cancelled out, then the angle theta is not affected by the value of the mass. So this sentence cannot explain what the error could be, and we would justify it with the mentioning of this equation and the fact that the mass cancels out. And this is enough. And we proceed to the next part, where we have a graph of acceleration and angle, sine of the angle, where immediately we need to draw the best fit line. We'll take a ruler and a pencil and try to draw a line that goes between the points. Some of the points should be a little bit above and some of the points should be a little bit below. Now my graph is not perfect. I need to decrease the slope just a little bit. I think this is good enough. And now it's a little bit better if we use the whole graph, maybe increase the slope just a bit, and I'm happy with this. And from this, we need to determine a value for the acceleration of gravity. Now, I believe that we're going to bring back the previous equation that we used, the force by the fan plus m times g times sine theta is equal to ma. And we can see that on the y-axis we have the acceleration, and on the x-axis we will have the sine theta. So we'll try to leave the acceleration alone. So first we divide over mass. Actually, I'm gonna divide over m here, over m here, over m here, and we bring that the acceleration is equal g sine theta plus force by the fan divided by mass. So we have brought the equation in the form of a straight line where, if you remember from math, y is equal a times x plus a factor b, where a is the slope of the graph. In this case, the a is our y, the sine theta is our x, and the g is our slope. So the value of g is just our slope, so we'll mention it that g is equal to the slope of this graph, which is rise over run. I'm going to mention delta y over delta x, and I will select any 2 points on this graph. Now I will select the beginning, and I will select, for example, the 0.1 seconds. What is the value of the graph at 0.1? Sorry, it's not seconds, it is the sine of theta. So the delta y is from approximately, this is exactly in the middle, 1.5 minus, now I need to see, I think it is again 0.5 divided by the delta x, which is 0.1 minus 0, and from this we bring exactly 10 meters per second squared, which is quite convenient for our purpose, very, very close to the real value of g, and we can move on. And finally, for part F, I think this is the last part of this question, we have the cart we replace the cart with a mass of 1 kg, and we need to find how would the graph, and if the graph would change. Now, the equation has this form, and the value of the mass is on the last factor, on the factor of b. If we remember from math, now the value of b represents the y-intercept. So the y-intercept is here, the value in this graph is 0.5. Now, if we bring a cart from that has a mass 1 kg, the initial value of the mass was 0.5 kgs, and we increase the mass to 1 kg. This increases the value of the denominator, so the whole y-intercept would get a smaller value. So everything would stay the same, the line would have the same slope, but the graph itself would be a little bit below. So we would mention that there will be, basically we need to explain why, because again we bring the equation g times sine theta plus force of the fan, which was, if I remember correctly, it was 0.4 divided by the mass. Increasing the mass decreases the y-intercept, so there would be a parallel displacement of the graph, of the graph, and the line would go under, the line would move below the original. And we finished the first question in 14 minutes, which is not too bad. Thank you for watching. If you have any question, you can write it on the comments. Thank you.